This is the handout for inductive reasoning, and it looks like this. We're gonna go ahead and fold it this way, like a brochure. So it'll go in here, and then the next one will go in here like this. So let's start on this side. Inductive reasoning is a pattern. So most of the time what we're looking at is numbers like this, and we want to see the pattern. 2 to 5 is adding 3. So 5 to 8, we're also adding 3. 8 to 11, we're also adding 3. So we know that the pattern each time will be adding by 3. Your answer does need to be in a complete sentence, so please write the pattern is adding by 3 each time. A counterexample is something that would be false. So it makes your statement that you have made not true. So for example, this is the statement that we have made. The sum of any two integers is positive. And we're looking for something that would make it not true. So let's talk about this for a little bit. Sum means addition, so we're adding two things together. And integer is all real numbers. So for example, 1, 2, 3, sorry, these are called natural numbers, 1, 2, 3, 4, and they're opposites. 0 is an integer, but so is -1, -2, -3, and so on. So a counterexample would be -1 plus -3. Those are integers that are added together, and that equals -4, making the statement that it made, that it's positive, false. A conjuncture is the conclusion, the concluding statement based on the reasoning. So this always needs to be a complete sentence, just like any other conclusion. Right here, what we're looking at is counterexamples. So we're going to do some counterexamples right here. Adjacent angles are congruent. Adjacent means next or together. They're stuck together. So if we got two angles stuck together, it's saying that it has to be congruent. The word congruent means equals. Let's take this example. I'm going to draw sort of like a right angle. I'm going to say that this is 60 degrees and this is 30 degrees. I like this example. There are adjacent, that means they're together. And they also make a counterexample because these are not equal. They're stuck together, but they're not equal, making it a counterexample. Complementary. The word complementary means that two angles together equal 90 degrees. A right angle also equals 90 degrees, but it's just one angle. So this is one angle that equals 90 degrees. That's what makes it a right angle. Complementary are two angles. So let's draw this picture. Let's say that that's 60 degrees. And that's 30 degrees. These two angles would be complementary because when you put them together, they do equal 90, but they're not together, they're not adjacent, so they can't form one that equals 90. So this would be a good example of complementary angles that equal a right angle. but this would be its counterexample. If we open this back up, we're going to be taking a look at this section first. It says make a conjecture. So we want a complete conclusion about the pattern and list the next term. So the first thing is to look at the pattern. How did we get from here to here? We're subtracting 15. This is an easier one to look at, that we're subtracting 15. Okay, that means that our sentence has to be the pattern is subtracting by 15 each time. The next thing that it asks for is what's the next number? So we're going to take negative 40 and subtract 15. Negative 55. Negative 55 is the next part of your answer because it says list the next term. So let's put it here instead because it wants a list. Number 2, it looks like it's multiplying by 4. Let's take a look. 0.25 times 4. Yes. 1 times 4. 4. Very good. So it is multiplying by 4 each time. So times 4, times 4, times 4. That means the pattern is multiplying by 4 each time, making the next number 16 times 4, 64. This looks like dividing by 5. So 5 divided by 5 is 1. 1 divided by 5 is the 0.2. So the pattern is dividing by 5 each time. So we have to take this one and then divide by 5 to get the next term in the pattern. Number 4. It looks like they're adding the previous term. So 1 plus 1 is 2. 1 plus 2, 3. 2 plus 3, 5. So the pattern is that the previous two terms are being added. That means that our next number is 5 plus 8, making it 13. All right, so we see the patterns. That is examples of induction when you see patterns. The next one is says make a conjuncture. So we want to make a complete statement about the relationship. Says, or we want to make a conclusion about the statement that it's making. It says there's an angle in P. And it's telling you that this angle, M in P, is a right angle. That means that angle M in P is equal to 90 degrees. If it's a right angle, it equals 90. We made a complete statement of a conclusion we can make. These two angles added together equal 90. This is a vocabulary word that we saw on our previous handout, which meant complementary. That means that we need to write that the angle A and angle B are complementary. Angles. Number 3. Point B is between point A and C. Okay, so between doesn't mean midpoint. I just want to make sure to point that out. I'm going to draw a little picture here, and this is A. Let's make this one really close to A, and that's B. And then I'm going to make C really far away. But we can still say that the segment AB plus the segment BC is equal to the segment AC. That means this little part plus this bigger part make up the whole thing. Triangle DEF is equilateral. So let's take a look. That means that DE is equal to EF is equal to DF. This segment is equal to this segment and this segment. Because it's equilateral, it means that all sides are congruent. Angle ABC and angle CBD form a linear pair. So what a linear pair is, a pair, so two angles that form a line. Two angles that form a line. Since they form a line, I'm going to make a sketch like this. Let's make this A, B, C for this angle, and C, B, D for this angle. Then we can say that the angle A, B, D is Supplementary. Well, what does supplementary mean? That means two angles that equal 180. So this word means that they equal 180 degrees. We haven't seen this vocabulary word yet, but we will soon, and I just want to slightly introduce it. Supplementary means that two angles added together equal 180 degrees. The point DE and F are non-collinear. So we have talked about this several times. What this is that once you have 3 points that are not collinear, there exists a plane. There exists a plane with the 3 points. All right, let's take a look at the bottom part. It says determine whether the conjecture is true or false. If it's false, provide a counterexample. Vertical angles is a word you haven't learned yet, but what vertical angles are is that if you cross two lines like this, so just two crossing lines, that the opposite angles are considered vertical. So let's call this one A and this one B. That means this angle and this angle. And this is actually a rule, a definition that we're going to learn later, so this will always be true. 2. If x is a real number, then 2x is greater than x. Let's pretend that x is -4. If that's the case, then 2 times -4 is -8. -8 is not greater than -4. Making this problem false. We cannot make this statement. It's not true. Because it's not true, we can find a counterexample. But sometimes it's easier to find that counterexample to prove it that it's false. 3. If two lines are perpendicular, okay, so let's make two perpendicular lines, then right angles are formed. Well, that is the definition of perpendicular, is that it makes right angles, so this will be true, always true. 4. If two angles are supplementary, so I have mentioned this word before, but we haven't quite learned it yet, so I'm going to say it again. That means two angles that equal 180 degrees. Together, these two angles equal 180 degrees. Then they form a linear pair. Okay, so you have to be careful with this. It says there's two of them, but it doesn't say that they have to be adjacent. Adjacent means together, stuck together. So we could have this angle and this angle that are not together and don't make a linear pair. So don't forget, a pair, two, they make a straight line. These don't make a straight line. They're disconnected, even though they might equal 180 degrees. So let's just give some values. Let's say that this is 120 degrees. That means that this one would have to be 60 degrees. Together they equal 180, but they do not form a line. They do not form a line. Okay, so this would be false. And that is a counterexample. 5. If the points Q, R, S are collinear, then QR plus RS equals QR. So sometimes the statement when they give it to you in reverse is true, but this statement is false. Let me tell you why it's false. Let's call this Q. Let's call this R. And let's call this S. So it's saying this segment plus this segment is supposed to equal to this. This one's longer. I know it's a little hard to tell, but this one will be longer, making it not true. And this is your counterexample. If AB is equal to BC, then B is the midpoint of AC. This one's also false, because we can have a similar situation from this one. And I did not read this carefully enough. It says if points Q, R, S are collinear. What does collinear mean? Collinear means that they are in a line. Q, R, S. So even if it's not a midpoint, for example, R is all the way over here, it's still true that this little segment plus this little segment equals the whole thing. Oh, Miss Hernandez, you gotta be careful. Read carefully. So this will always be true. Okay, so what was the difference? I saw the points Q, R, S, but I didn't read carefully enough to say that they were collinear. That means on the same line, making the statement true. Well, why did I notice that? The reason that I noticed that is because this statement says that the segment AB is equal to BC, but it doesn't tell me that they're collinear. So this is the example that I was thinking of with AB and BC. And it is the midpoint, so they are equal. No. Let me try this again. Tells me that the segments are equal. Then B, so I'm trying to prove this part. Then B is the midpoint. So let's see, AC. Is B in the middle? No. So it is false. Let's try this again. What I said was that they tell us that the two segments are equal. That's the only information that's given. This then part is the part that we're trying to disprove, if it's possible to disprove. Then B is in the middle, the midpoint of AC. Well, it doesn't say that they're linear. It doesn't give any indication of how these points are supposed to be. So this is still false. Sorry that I made some errors, but I hope you still understood. Let me know if you have any questions. I would love to hear from you.